Hey everyone, Fabian999 Notification here today with another Redstone video. And today I'm going to show you my 4-bit computer. So yeah, let's get started. Okay, so this 4-bit computer is a lot different than the 8-bit computer that I showed you before. The architecture is completely different, and programming it is much different as well. So over here is the power control, so you can turn on debug mode, you can turn the clock on and off, reset the program counter, single step, resume, and if the clock has halted. And also over there is just the clock LED. Over here you can deposit and examine memory locations. Here's where you select memory locations. Here's your data, or the opcode. Here's your opcode / bus display, and your address bus display, and here is where the bus is displayed. The bus is just over here if you're wondering. So yeah, the memory is completely blank, it's completely zeros. So let's just write a program. The program I'm going to be writing is 3 plus 3, and at the end it's going to halt. So let's get started. Let's reset the bus, deposit. Okay, now I'm gonna go address 1. I'm going to set the bus to 3, deposit. And 2, I'm gonna put it in 1. The next one is going to be a 2. And now it's going to be a 12. Deposit. And now it's going to be a 3. And now we need a 13 because we want to sit and watch it there. So now our program is toggled in now. And you can examine all of the lines to see if it's correct, but for example I'm just gonna display line 6, examine. Here we are, it lit up 6, and this is the value that's in it. And when you do a examine, make sure you also reset the program counter, because when you examine it sets the program counter to that value, and then you have to reset it. It's a little bit inconvenient, but you know, it's just how it works. So now program's toggled in, so let's run it. And it should be done soon. It should halt at line 6. And here we are. So the bus is being displayed, and we get the correct answer, 6. 4 plus 2 is 6. There we are. The program added 2 numbers. And also the clock is halted, which is good. Now we're going to turn off the clock, and when you turn the clock off it doesn't reset the program counter, because when you're programming it might, you know, because when you have it off you're usually programming it, and then it's just gonna screw up with your program. so I decided not to do that. Also, when you turn it off, it automatically turns off the clock, or it technically resumes it, but it's off right now. It's completely off. So yeah, and also what debug mode does is it runs a program, but it doesn't turn on the clock. So it's sort of a simulation of deposit next, I guess. Examine next. So if I debug, you're going to see all these lights here, but the clock isn't running, but the program is running. So if I single step it, it goes through one cycle at a time. As you can see, it incremented the address bus, and now we're gonna single step again. And there we are, it does it all. So just be aware that debug mode turns on the program, so your commands are still flying in, but the clock isn't turning on, which is exactly what debug is for. And resume clock just simply resumes the clock, and reset program counter just simply resets the computer if the clock is on. And here I'm going to show you the insides of it. It currently has 4 bytes of memory, which is incredibly small. It only has 8 lines. You can't really do anything with this. This is just an experiment with what I could do with Redstone. But you know, it's sort of useful because it's very lagless and only does one thing at a time. The reason why it's so slow is because it has to go through the program counter, then through this decoder, then it has to read a location for memory, go through all the way to this bus, then goes to that decoder, which is a control unit, and then it goes to all the commands. So it is a bit slow, but it's worth it. Well, for me it is. This is the ALU right here. It's a lot more simple than the 8-bit computer one. This one is just an addition ALU. It just does addition, nothing else. Very, very simple. The reason why I only did addition and nothing else is because the control unit is very small. If I had an 8-bit computer, I could probably put subtraction and logical things in there, but then the decoder will be way too large, be like 255 blocks over there, and it'll just run way too slow, and this over here would be just flying over there, just ridiculous. Yeah, I think that's about it for this video, and yeah, that is about it. Thanks for watching, and I totally forgot the clock speed is 32 ticks, which is quite a bit slower than the 8-bit computer. So yes, this is really the end of the video. Thanks for watching.